In this video, I will provide an overview of the econometrics models that I have taught and posted on my Econometrics Academy website and YouTube channel. I find that it's very useful to provide a quick overview so that people could get an idea about what each of these models are all about and what's covered into each of these videos before they proceed into the particular models. Likewise, if you're sitting in front of a big data set and you're trying to come up with some good models to do for your research, this video will help you get an idea about how the data looks like and which of the models may be more applicable to your research than others. So these are the econometrics models that I will provide an overview for and that I have taught in more detail, and all the materials are posted on the website and YouTube. We will start with the linear regression model and then go into panel data models and then do the Probit and Logit models, including the binary ones, the multinomial and ordered ones. We will continue with limited dependent variable models, count data models, and then we will go into instrumental variables, seemingly unrelated regressions, and we will conclude with more specific topics of survival analysis, propensity score matching, spatial econometrics, and quantile regression. And I will also have videos on how to do time series models. There is no order of these topics. Each topic is a standalone topic that you can just pick and follow. I would suggest, though, that if you're new to econometrics, to first watch the linear regression because it's a great overview, and I'm going slower in these videos and they're a prerequisite for the rest of the course. Also, if you're looking at the Probits and Logits, make sure that you watch the Probit and Logit models first, the binary ones, because it greatly helps in understanding the other two videos. But other than that, just pick a topic that you like or whichever ones you like, and you can watch and follow them along with me. Okay, so the beginning point of every econometrics class is linear regression. And here are a few examples. We can study the effect of hours studied on student grades, the effect of education on income, the effect of recession on stock returns, and so on. So we have dependent and independent variables here. The dependent variable is a continuous variable in these models, and the independent variables can take any form: continuous, discrete, indicator variables, or a combination of these. It doesn't matter. So these are the few things that we will discuss in that linear regression videos. First of all, we will talk about the models, then about the coefficients and marginal effects, and we will interpret them. We will also talk about tests for coefficient significance, including the t-test for one coefficient significance and f-test for joint or overall significance. We will talk about how to do predictions of the dependent variable, and we will conclude with goodness of fit, or the R-squared and adjusted R-squared. So this is the plain vanilla ordinary least squares OLS models that everyone should know about. Next ones are panel data models, and here are a couple examples from labor economics. We can study the effect of education on income, where you have the data across time and individuals, and in economics you can study the effects of income on savings with data across years and countries. So notice one thing about the panel data characteristics is that we have information on individual behavior. We have that information is both across individuals and over time. So we have both cross-sectional and time series dimensions, which makes it into a panel data and necessitates the use of panel data models. So the panel data can be balanced, where all individuals are observed in all time periods, or unbalanced when some individuals are not observed in all time periods. And all the software could deal with both of these kinds of data sets. So particularly in the video on panel data models, we will talk about the characteristics and panel data types. Then we will talk about variation type, including the overall, within, and between variation, exploring the cross-sectional and time series dimensions of the data. Then we will talk about the specific panel data models, including the pooled model, the fixed effects model, and the random effects model. And we will talk about the estimator properties, including the consistency and efficiency of estimators. And then we will talk about the estimators that we can use to estimate those models, including pooled OLS, between, fixed, first differences, and random effects estimator. We will conclude with tests for choosing between the models, including the Bruch-Pagan test and the Hausmann test. The next topic would be Probit and Logit models, and here is the binary outcome examples. From consumer economics, you could have whether or not a consumer makes a purchase. From labor economics, you could have whether an individual participates in the labor market or not, and from agriculture economics would be whether or not a farmer adopts or uses organic practices, marketing, production contracts, and so on. So notice here that the dependent variable is a binary response variable. It is commonly coded as a 0-1 variable. It's not continuous, just two categories, 0 or 1. And the decisions or the choice is whether or not to have something or to do something or to use something or to adopt something. These are kind of like the choices that we have. So when we talk about the Probit and Logit models, we will compare the linear regression model, which is not a good alternative for these kinds of data, and then the Probit and Logit models, the functional forms and properties. We will talk about the model coefficients and interpretations, and this is when the coefficient and their interpretation become more challenging, so we will be using the marginal effects and odds ratios in their interpretations. We will talk about goodness of fit statistics, including the percent correctly predicted values, as well as the pseudo R-squared, which is similar to the R-squared that we use for other models. We'll talk about the choice between Probit and Logit model, and my conclusion is just use one of them. And the economic models that lead to the use of these Probit and Logit models. So now that we have talked about the binary 0-1 Probit and Logit models, we could talk about the multinomial Probit and Logit models, where here the examples are the type of insurance contract that an individual selects. We can talk about the product that an individual selects, such as type of cereal or occupational choice by an individual, business, academic, or nonprofit organization. The dependent variable here is a categorical, and it's also unordered variable. So we can code these categories or choices as 1, 2, 3, 4, or any other numbers, or just leave it as the categories because the numbers don't mean anything in this case. And in this case, we would have that an individual may select only one alternative. So only one choice is allowed for each individual in these kinds of models. Then in the video we will discuss the multinomial outcome dependent variable, where we have wide and long forms of data sets, which means are the choices on separate rows or like in one long row. We will talk about the independent variables. Do they vary with the alternative or the choice that individual makes, such as the price or the quantity of an alternative, or do they not vary, such as income, education, which is specific to the person. And then we will talk about the multinomial Logit model, including the coefficients, marginal effects, and IIA property, and the multinomial Probit model. And then we will talk about conditional Logit model and the mixed Logit model, or the random parameters models. So these are all types of multinomial Probit and Logit models. Another type of these Probit and Logit models is the ordered ones. And here we have as a dependent variable, say we can have ranking systems: poor, fair, good, or excellent; opinion surveys: strongly agree, agree, neutral, disagree, or strongly agree; employed, where it varies with intensity from unemployed, part-time, or full-time; ranking of students such as senior, junior, sophomore, and freshman, grades A, B, C, D, and E, what we use in the States, and bond ratings, including AAA, AA, A, and so on. So here the dependent variable is ordered, which means that the categories are rankings, so the numbers don't make sense because the difference between them isn't necessarily doesn't have any meaning, but they're ordered. So we know which one follows after which one. And here we would talk about the ordered outcome dependent variable and the ordered Probit and Logit models, including the coefficients and marginal effects and how we need to interpret them. The next types of models are the limited dependent variable models. And here are a few examples. We can talk about the quantity of product consumed. And many people would have zeros, they don't consume that product, and some would have positive values. From labor economics, it could be the labor supply or the hours worked by women. So again, you would have zeros or positive values. You could also have capacity issues, such as the demand for tickets for a game or a conference, where that is limited by the capacity for the hall or the stadium. So the limited dependent variable would be that there's some limit or boundary on the dependent variable, and some observations hit this limit. So the variable would be a continuous variable with lots of repeated observations, either at the lower or the upper limit. And most commonly, we have a lot of zeros in the data for the dependent variable. We will talk about two different things, including censoring and truncation. Censoring is when we have those observations that are zeros or hit the limit in the sample, and truncation is when we don't have them in the sample, meaning we did not survey them. And the limited dependent variable models that we will consider are the Probit model that uses the censored sample, all of them, the zeros and the positives, the truncated regression that just uses the truncated sample or just the positives, and the Heckman model, which is a sample selection model. And this is when people self-select into do they do something or not, and then we estimate the outcome variable for them. Next are count data models, and here are a few examples when we have consumer demand, such as the number of products that a consumer buys on Amazon. It could be recreational data, which is the number of trips taken per year. From family economics, you can have the number of children a couple has, or the demand for health demand, which is the number of doctor's visits. Notice that in this case, the dependent variable is counts. It's a non-negative integer, which is 0, 1, 2, 3, 4, and so on, where we have all the sample concentrated on a few small discrete values, such as we have a lot of zeros and lots of maybe from 1 to 10s or something like that. But it's not in the thousands the way the variable is measured typically. So we will talk about several types of models, including the Poisson models and the negative binomial model, where we relax some of the restrictive assumptions of the Poisson model, particularly we correct for over-dispersion. And then we will talk about two particular types of models, the hurdle or two-part models, where we split the zero or positive decision from how many of the positive, and the zero inflated models where we're trying to explain where the zeros came, and they could come from two ways. One is when you just don't like something, and another way is in which you like something but you may not have done it. The next type of model is the instrumental variables models. And here are a couple examples of endogeneity. In this case, wages and education would jointly depend on the ability of a person which is not directly observable. And we can use available test results to proxy for this ability and correct for the fact that we have endogenous variables. Or consumption and income could be both determined by macroeconomic factors, and in this way we can use, say, investments to control for endogeneity. So in this case we have regressors that are endogenous, meaning they're correlated with the error term. And we need to find instruments that are correlated with these endogenous regressors but uncorrelated with the error terms. We will talk about the instrumental variable procedure, which is this two-stage least squares estimation procedure, where we use the instruments and then we get the fitted values for the endogenous variable, and we plug it into the second stage estimation to do the estimation for the dependent variable. We will talk about identification issues and endogeneity test, weak instrumental variables, and we will also talk about systems of equations with endogenous variables, where we can apply both the two-stage least squares and the three-stage least squares approach. And a related topic is seemingly unrelated regressions. In this case, we have demand system for food items for individuals, such as meat, vegetables, fruits, and so on. We can have expenditure systems for several different types of expenditures, such as housing, education, entertainment, and so on. And we can have demand and supply models. So in this case, when we have systems of equations, they would have multiple equations, and the simultaneous equation models would contain both endogenous and exogenous regressors, like the previous model that we work with instrumental variables. But the seemingly unrelated regressions contains only exogenous regressors. That's why we're saying that they're seemingly unrelated, because their relation is through the error terms. We will talk about the SUR model, the seemingly unrelated model, the estimation, and the properties of the SUR model. Okay, next one is survival analysis. So an example from finance is how to do is to look at loan performance. So borrowers obtain loans and they either default or they continue to repay their loans. In economics, we can talk about firm survival. They're in the sample until they're surviving and then they exit. And another example is time to retirement, time to find a job, and how long does it take you to do these. So the setup for survival analysis is the following. Subjects are tracked until an event happens, which we call failure. It may be a good event, but that's the terminology. We call this event a failure. Or we lose them from the sample because they may leave the sample for other unrelated reasons. And we're interested in how long they stay in the sample, which is their survival, what we call survival. And we're also interested in their risk of failure hazard rates, which would be different depending on when they're at, depending on how long they have been in the sample and they have been surviving. So in that video, we will talk about the survival analysis setup and features, the extensions of the basic survival analysis, and then about the survival hazard and cumulative hazard functions. They're very important in survival analysis. We will talk about non-parametric analysis, the Kaplan-Meier survival function, and how to plot graphically the data that you have. And then we will talk about parametric models, the exponential, Weibull, Gompertz, and log logistic, and the semi-parametric model, the Cox proportional hazard model. Next one is propensity score matching. And here is an example of treatment evaluation where we can attempt to study the effects of training programs on job performance. So does the program help? Do individuals who enroll in a particular program, is their job performance better? Or we can study the government programs targeted to help schools and their effects on student performance. So do schools that participate in certain types of government programs have higher student performance. So treatment evaluation is the estimation of the average effects of a program or a treatment on the outcome of interest. We want to know, does the treatment help? And the comparison of the outcomes is between the treated and the controlled observations. And one of the big problems is that we're not randomly assigning people into these two groups. So we need to match them as well as possible before we compare their outcomes. So this is the methodology of the propensity score matching. First, we would put people in treated and control groups, and then we will estimate Probit or Logit models to estimate their propensity to be in the treated group. Then we will talk about matching methods for treated and controlled observation, how you can match those two groups. And we will talk about the treatment effects after the estimation, or how to compare their outcomes once they're matched. We will talk about the assumptions in propensity score matching, and then we will conclude with difference in differences models when we have 2 or more periods of data. In spatial econometrics, a few examples is when the house prices depend on number of bedrooms, bathrooms, and so on, which would just make it a linear regression. But they also depend on the location because the prices of the houses in the same neighborhood are similar, so they influence each other. In farmland values, you could have the farmland prices depend on land rent, on the government payments, and so on. But those prices would also be similar if those farms are located in counties that are spatially close. And in precision agriculture, we could have different rates of nitrogen applying to corn fields, and corn yields will be different because different applications would lead to different yields. But because of the characteristics of fields that are close, we would have some spatial correlation in there. So, spatial econometrics accounts for the presence of spatial effects in regression analysis, and we would talk about the spatial weight matrix. So we want to know who of our observations, who is a neighbor of who, and how are they related. And we will use 2 criteria based on contiguity, whether or not like counties or objects touch each other, and on distance, how far away they're from each other. And we will estimate 2 types of models, the spatial lag model and the spatial error model, depending on where that spatial correlation is coming in, for the dependent variable or for the error term. And we will also talk about the spatial dependence test. Next one is quantile regression. Here are a couple examples from consumer economics, the effects of household income on food expenditures. And you can say that it depends on whether or not we have low food expenditure households and high food expenditure households, and we want to know their effects along the distribution of the food expenditures. For education, we could study the factors affecting student scores along their score distribution. So we want to know what factors affect those high performing students and what factors affect the low performing students. So in quantile regression, it would give you a more comprehensive picture of the effect of the independent variable on the dependent variable along all the quantiles or the distribution of the dependent variable. And it's important that in this case we have a dependent variable that is continuous with no zeros or too many repeated values. So we need to have nice and continuous kind of variable to be able to use quantile regression. In those videos, we will talk about the quantile regression model, the coefficients and marginal effects. And one thing that becomes very important is how do those quantile coefficients would differ from the normal OLS regression coefficients. And we will also talk about the advantages of quantile regression and why use it. Finally, we will conclude with time series models, and This is when we model the relationship of variables over time, such as commodity prices or crop yields, or we can analyze the effects of a specific event, such as the effect of recession on unemployment rates or stock prices or something like that. And it's very much used in forecasting when we want to predict economic growth or future prices. So the data are time series data, which means that variables are measured over time, and this is the primary interest for our estimation, is these variables measured over time. In those videos, we will talk about testing for stationarity using the Dickey-Fuller test, and we will talk about how to deal with data that's non-stationary, including differencing and trend removal. And then we can test for autocorrelation with the ACF and partial autocorrelation with the PACF functions. And we will talk about the autoregressive models and the moving averages models that we can use to correct for these types of autocorrelation. And I will also describe the Box-Jenkins methodology for selecting a model. So this is a very quick overview of the models that I currently teach and are posted on the website and YouTube channel. And I hope you like the overview. And now that you know which model you need, please take a look at the particular models with much more details on how the models work, a few examples, and also how to estimate these using different software and data. Thank you for watching.